Hey everyone, my name is Catherine Renaud, and today I'm presenting my research project called When Smart Devices Outsmart Themselves, Cybersecurity Risk and AIoT. This is for Cyber 4893. To start, the combination of AI and IoT creates systems that can learn, analyze information, and make decisions without people being hugely directly involved. The number of connected devices across the world is already in the billions, which means the amount of technology that is making its own decisions is growing exceptionally fast. Now, with that growth comes a much larger attack surface. As we're going to get into in later slides, traditional IoT was already a security challenge within itself, but adding these AI components has now changed the threat model and even given us some additional things to have to consider moving forward. Because now, instead of attacking hardware or networks, attackers can now target the logic and perception of the AI itself. In this presentation, my goal is basically going to be to explain what AIoT is, what IoT is, how they're both vulnerable in some pretty different but similar ways, and how we can do things and take steps to mitigate the risks to these systems. We're going to start with IoT first, kind of going over what IoT means, what it stands for, and the benefits of having it in your home. So the Internet of Things is essentially a network of connected devices that collect and transmit data. You can see it in everyday smart thermostats, watches, medical monitors, even in some industrial sensors and manufacturing. We see here that IoT can offer a lot of benefits, like it improves efficiency, reduces cost, makes monitoring easier. It even improves safety and provides smoother user experiences. The scaling is also very, very easy, which means that industries are starting to rely upon this even more and more as their businesses grow. All of these details are important because IoT is the foundation that AIoT builds on. And we're going to go into AIoT now. AIoT, as we can refer to from earlier, is what happens when AI is added to IoT systems. Instead of just collecting data like IoT does, these devices can now analyze that information, learn the patterns from those data points, and then take on actions either on their own or with user approval. This brings a slew of new capabilities, like predicting when something will fail, making decisions instantly, responding to context with proper context, improving overall human accuracy, and adapting over time to their user as they learn. Essentially, with all of these details in mind, we see that AI transforms IoT from a passive system to an intelligent system. But that can also leave some new places where attackers can strike. We're going to go over here to what is going to be known as the IoT versus AIoT weaknesses table. We're going to start with our weaknesses from the traditional IoT and see how that builds and even has some elements in the AIoT field. Now, traditional IoT has weaknesses that most people are familiar with, like weak passwords, old firmware, and insecure networks. These issues mostly affect the physical device or the network that the device is connected to. And we can see over here that we have some more things with AIoT, but I'll explain this as simply as possible. AIoT includes all of the problems listed under IoT, but then it adds 4 more that you see below. These attacks that you see below are attacks on the data, the model, and the way the system makes decisions. This can include, as mentioned below, data poisoning, adversarial examples, prompt injection, and model manipulation. These attacks don't focus on breaking into devices. Instead, they target how the AI understands and reacts to the world around it. We'll get into case study 1, which is an adversarial example. Basically, our first case study shows how simple changes in the physical world can fool an AI system. As we can see, in 2017 and 2018, researchers discovered that small additions like stickers or tape on stop signs can cause an autonomous vehicle's camera to misread the sign. To a human, the sign still looked like a normal stop sign, but to the AI system, it appeared as a speed sign or sometimes didn't even register as a sign at all. This demonstrates how extremely small changes in the real world can cause major safety failures in systems that AI relies on to understand the environment. And in a lot of cases, things like this can lead to some pretty serious consequences, even up to and including loss of life. We'll go into our second example now, which is going to be a data poisoning example. Basically, the second case study is going to focus on data poisoning for this. From 2020 to 2024, attackers kind of quietly altered some portions of training data that was being used by an AIoT system in manufacturing and utility environment. By changing this small amount of data, they basically caused the AI model to learn incorrect patterns. As a result, the AI made faulty predictions and unsafe automated choices. This shows that even minor changes to training data can damage the entire decision-making process of an AIoT system. When the model learns something wrong, basically every connected device follows those incorrect instructions. And even this can result in loss of life. And that's why taking these precautions and that we're going to talk about later and understanding the real consequences of what could happen, worst case scenario, with these attack patterns is deeply important. Now, our third case study, and we're not going to go over all four concepts, we're just going to go over three today. But the third case study is about prompt injection and connected vehicles, again, autonomous stuff. But from 2024 to 2025, researchers basically found that voice-controlled vehicle assistants could be tricked by hiding malicious phrases inside normal audio. These prompts could be placed inside songs, background noise, or spoken command. When the car's AI processed the audio, it picked up on hidden instructions and performed actions that the driver never intended to happen. Some examples include disabling safety features or sending sensitive data to third parties. This matters because when the attacker does not have to hack the car directly, they only have to influence what the AI hears or reads. And at that point, we've established a whole new kind of social engineering, but it's AI social engineering. It's artificial engineering, if you will. And because of that, we have to start acknowledging that maybe AI isn't solve all to the social engineering issues that we experience on a daily basis and what's really costing companies billions of dollars of revenue every year. Well, now we are on my favorite portion, which is the mitigation strategies. So we're going to go over some different kinds of mitigation strategies, but I'm going to go over three for now. This one is going to be the adversarial training. Basically, the first major defense is going to be this. Adversarial training basically works by showing the AI a lot of manipulated examples during its training. The idea is that if the model learns to identify these attacks early, then it becomes actually a lot harder to fool the AI with bad data later. This process basically improves the system's resilience against adversarial examples and certain types of data poisoning. It essentially teaches the AI what malicious manipulation looks like before it ever actually encounters it in the real world. And I think this is a really important thing that people are going to need moving forward. I honestly think that when people make these AI models, there should be a dedicated subsystem for error correction. And I think that that stuff should have to be audited and monitored almost every couple of months, if not every month. And I think that this should apply to live deployed things along with things that are deployed in enterprise settings. Now let's go over our second mitigation strategy, which is called input sanitization. This basically means checking and filtering all incoming data before the AI model actually uses it. This is not training data, but the contextual data that usually either comes from the environment itself or from the user's input. Now, when the system scans sensor data, images, voice commands, and text for irregularities and rejects anything that looks suspicious or corrupted. This helps prevent data poisoning and reduces the chances that the model will be influenced by manipulated inputs. Sanitizing inputs kind of acts like a firewall that protects the AI from being fed harmful information. So for instance, we would have to have somebody, let's say, drive around to all the stop signs in the area and make sure that they've scraped off all the stickers and that the paint's correct and that it's not chipping and that there are things that aren't damaged on the sign that would prevent somebody from being able to read it correctly. Or even if somebody went around and put, let's say, a sheen so that no sticker sticks to the sign, or that somebody can't paint over it, well, then you would reduce the level of harm. Basically, by sanitizing your data and making it so that it's not necessarily confirmation bias, but so that there's nothing harmful contained in the data that it's using, it prevents a lot of data poisoning and in some cases data manipulation or model manipulation. When we come to our third strategy, this is, I feel like, the most common sense and important, but we still haven't even deployed it on IoT devices yet. But the third strategy is going to be zero trust architecture. Basically, zero trust operates on one simple rule. Nothing is trusted automatically. Every request, every device has to be verified, and this approaches limits on like how far, and this kind of approaches and mitigates the limits of how far an attacker can move through a system once they compromise a single device. It also keeps strict control over what each device is allowed to do and gives it parameters so that it can't function outside of that segmented parameter. And I think zero trust is specifically going to be effective for AIoT because it protects both the network and the data that the AI relies on. Zero trust is more of a philosophy than it is a strict ideological concept, at least based on the research that I have done. Now, with all of this stuff together, the combination of AI and IoT is clearly just transforming how technology operates overall and how we use it overall. These systems are just becoming more and more intelligent, more and more independent, but we have to admit that with that independence has now come a new set of security challenges. The case studies we looked at show that attacks on AI logic can have some serious and real life-altering consequences to them. Adversarial manipulation, data poisoning, and prompt injection. These are not theoretical ideas. These are things that have already been tried and tested. They're real problems that affect the safety of not just our basic infrastructure, but of our critical systems that provide food, water, transportation. And because of all of this, we need strategies, like a lot of the ones that I mentioned earlier, implemented that are designed specifically for the safety and continuity of AI. Techniques like the adversarial training, input sanitization, and zero trust can really help these systems continue to be productive as they grow. Now, securing AIoT is essential for the future of all kinds of infrastructure. Smart infrastructure, autonomous vehicles, manufacturing, everything else that depends on this technology needs to be protected. This slide here is going to be our last slide together. Thank you guys for watching my presentation. Thank you guys for giving feedback if you are on D2L or even on YouTube in the comments section. I really appreciate it. I felt like this was an important topic to talk about, and when I got the opportunity in class to discuss it, I thought that there was no more important topic to discuss. But as you can see right here are my list of references. If you want to use that, I'll probably put it in the description of the video if I can. If not, feel free to kind of look up this information. I just pointed at myself, but ignore that. So I'm going to keep it up here for just another couple of seconds, maybe talk some excessively. All right, so that's all you get. If you can't pause the video or don't want to, maybe try commenting on the video or in the description below, and I'll try to get you that information, guys. But I hope you guys have a great rest of your day, and I look forward to all of the stuff that we'll be seeing for these projects.